All right. Good morning. And here we are again for another episode of Cosmic Matters. It is Sunday, January 19th, 18th. I think it's the 18th, January 18th. It is snowing where I am. It's been snowing all morning. And, I am Matthew Washington and the Matt in Matthew in Cosmic Matters. And, I created this Matters series to kind of give you a different perspective on the world, have you think a little bit outside of your normal thought processes and discuss things that do they matter? Well, it depends because what matters is constantly dependent upon you. But we like to just expand the thought process here on Sundays and try to entertain your brain for a little bit of time. So we are live here on YouTube, Philosophy Man 76. We also on stereo. I didn't bring up TikTok this morning, and today we're going to talk about consciousness. We're going to do a little star talk first before I get into it. Before I talk about, because I want to just share what's going on and some thoughts. I learned some new things about space. Thank you, Neil deGrasse Tyson, and share some of that, and then we'll get into the main topic of consciousness. And but I had an experience. Universe, every week I think, am I going to do this podcast again? Should I do another one? And I was driving, Lyft or Uber, well, Lyft basically, the other day. Actually yesterday, and I picked up G. She only had a letter for a name, and we were talking, and then I started talking about how I was doing these podcasts on stereo during COVID, and how that kind of brought people together and gave us an outlet to talk to each other. And now that stereo is not as big as it used to be, I still do this. And I talked about how I met, Muhammad, who joins us over here and there on the show, and we used to do shows together. And then I talked to her about this podcast that I do, and she was so excited. She was like, "Oh, where is it? Where can I find it?" And she jumped on Spotify. So I told her to start episode 3. So G, if you're here at episode 20. Thank you for listening again for so many shows, and we'll give you a little shout out there to give me the motivation to keep going and doing this again today. But let me plug this in. Also, I have this wonderful person who used to work for me a long time ago. And she is a born again Christian, and or I guess born again Christian. I don't know what she would title herself, but Christian. And she posts pretty frequently on Facebook and Instagram, and she gets very upset because I can't not respond when nonsense is when what I feel is nonsense is spoken. And when I say nonsense, I mean, I don't mean it in a derogatory way, although people seem to take it that way, and you can take it that way, and it can be used that way. But I mean literally the word no sense. Like, this person is not making sense based upon the things that they are saying. And one of the things she was talking about on her little video was one about the flat earth. Okay, and the flat earth is just so funny, but the reason she gave for why there was a flat earth was because of what it says in the Bible and the firmament, and this is what the Bible says. And she said, why would we believe scientists who will say one thing one day, and then I think she said something like, why would you believe the scientists who tell us now that men can be women, or something along those lines? If the scientists are telling you that, why would you believe them about a round Earth or a spherical Earth? And what I there's so many things that are wrong with all of that. Like I said, like the first thing wrong is the scientists is a very vague it's a pretty vague statement. The scientists who are telling you about astrophysics and then the Earth being round are not the same scientists, quote unquote scientists, that are telling you about gender roles. The one's called biologists, and I don't even think biologists talk about gender. They talk about actual sex, the sex of a male and a female, which is different than gender. But astrophysicists are not telling anything about that. And I said to her, I was like, if I just said all God, thank you for the hearts. If I said all God believers why would I believe God believers? Well, God believers tell me that, Zeus throws lightning bolts. And, I'm like, there's a difference between God believers and Christians, right? And just like there's not just like scientists. So that's the first thing. Now, that led me down a path of a very interesting podcast that I always watch. Well, I don't always watch it. I watch from time to time. I'll watch Star Talk with Neil deGrasse Tyson. And he was talking about, and I will get to our topic, but these are just interesting things that happen throughout the week that I like to share before I dive into the consciousness part. But he was talking about the Big Dipper and the North Star and some things that I learned, which was very interesting, which I thought I would repeat. And by the way, you could just go watch Star Talk and you'll hear the same things that I'm about to say, but the different mediums, different settings, people get information from different places. So this is just interesting stuff that I found interesting. So first off, he said, if you ask most people what is the brightest star in the sky, in most people, a lot of people, a significant amount of people would say the North Star, right? Polaris. And this is the thing that actually it's kind of funny because it's going to throw me in a tangent. By the way, if you haven't listened to me before, I do a lot of tangents. Tangents are my thing, but I eventually will backtrack to my original point. So, my friend who believes in the firmament and the flat Earth just also posted something about what was it? Yeah, there was a Greenland thing. She said we need to take over Greenland because we need to protect us for ourselves because the distance from us, from Russia and China and our enemies, is what helps protect us from our enemies. And I had to remind her that, I know you're a flat earthist, but Russia is 2.5 miles away from America. I mean, you could, if there was no water, you could walk there in 30 minutes from Alaska to the tip of Russia. But I guess that, if you only, so yeah, that was the point. So it was the idea of, no, lost it. Anyway. Oh, yes. So the flat Earth again. So one of the biggest things that when I chat, the very rare times I chat with flat earthers is, and the one evidence I try to give them that is, I think is rock solid, is that you can't see stars. The night sky is different if you're in the southern hemisphere versus the northern hemisphere once you pass the equator. Why? Because obviously, if you're on the southern part of the ball, not the bottom, by the way, just call it southern because there's no up or down in space. But if you're on the southern part and you're looking at the sky, you can't see the sky of the northern hemisphere. You're looking at different skies, right? So it's pretty simple. You can't see the Southern Cross if you're in North America, and you can't see the North Star if you're in South America. Like, that's just how it goes. The North Star. So when I was talking about the North Star before, the North Star is not the brightest star in the sky. It's not even the 10th brightest star. It's not even the 20th brightest star. It's not even the 30th brightest star. It's not even the 40th brightest star. It is actually the 49th brightest star in our sky. Now, why do people think the North Star is the brightest star? Well, a couple of reasons for that. One, they've just been told it and they don't actually look. They don't, we're just told things. And by the way, I don't blame people. You can't possibly go and look up everything. And I think also because people think of the North Star as like the star that, travelers, back in the olden days in the 1700s and whatnot would use to guide their ships and whatnot. So they kind of assume it's the brightest star, but that's just it's not true. And it's fine. We believe a lot of things that aren't true. I ask people all the time, like what season do the days get longer and what season do the days get shorter? And most people think that the days get longer in the summertime and the days get shorter in the wintertime. But if you think, what is the shortest day of the year? The shortest day of the year, if you don't know, is the winter solstice, which is December 22nd. And then the sun is at lowest in the sky for 3 days, 22nd, 23rd, 23rd, 24th, right? And then it starts rising again on the 25th, which is one of the reasons why Christmas is the 25th. It's the rising of the sun, right? This has nothing to do with actual Jesus's birthday. But anyway, it's a whole nother topic. So, but anyway, the point being is, so if the winter solstice, if that's the lowest, if that's the shortest day of the year on December 22nd, then every single day after that has to be getting longer, right? So the days aren't getting shorter in the winter, they're getting longer in the winter, but it just takes time for that to happen. And it's the same thing in reverse. The first day of summer is I forget what the summer solstice is again, but whatever. The point being is the sun is at its highest point, and then throughout the summer it's something in like June. I think it's early June, and then every day after that is shorter, leading to the winter solstice. So the days get shorter in the summer and they get longer in the winter, but they just happen to be. It takes a while for it to get to the point where we notice it, right? So we assume these things. We have these assumptions or these things that we've learned that we haven't really dove into. We haven't really looked into it. So my friend said, just did she was doing a, should we believe, I didn't even watch the whole video. I got 26 seconds in and then I had to make a comment and I just stopped because I couldn't this morning. But she made a video about the should we believe scientists or should we believe the Bible? And she's like, and then the first line of the Bible is, in the beginning, in the beginning something or other, right? I can't remember. I read the Bible and studied the Bible a long time ago, and I've eliminated that knowledge from my head. But anyway, something like in the beginning, there was God, right? And she stopped there and she's like, right there, see the beginning of time and matter. And then she flashed up a book called The Origin of Time and Stephen Hawking's Final Theory, which wasn't written by Stephen Hawking. And she has a cover of it. And she says, see, scientists say that the time in the beginning of time, blah, 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 blah. There was no space, there was no time, and it all started from somewhere. So this is not what Hawking's or scientists say. It just happens to be the title of the book. The title of the book is The Origin of Time. It doesn't necessarily mean that's what Hawking's and even if Hawking's believed it, that time began that way, it doesn't mean all of science does that. But then I said to her, hey, maybe you should actually open that book and read it a little bit as opposed to just looking at the cover. Because then I went on to Grok and I pulled up some information about Hawking's and his theory of model of time. It says Hawking's and Hartl's model eliminates the singularity using, well, let me start here. In standard Big Bang cosmology, the universe starts from a singularity about 13.8 billion years ago, where time itself begins. But this creates paradoxes. What caused the singularity? What was before the singularity? Hawking's and Hart's model eliminates the singularity using quantum cosmology. And by the way, Big Bang theory is another thing that people don't usually look into. I'm going to read more of that in a second. That people don't look into is the reason why they call it the Big Bang is because it's a expansion. It's an expansion of time and space from a singularity. Now, why do they think there was a singularity? Because of redshift. Because well, the evidence was redshift, and Edward Hubble, which they named the Hubble telescope after. And what he noticed is that everything in the universe, the stars, and everything were moving away from each other, right? And you can see which way something is traveling based upon how shifted the light is as it reaches you, right? If something is coming near you, or it should be the farther away the something gets, it goes more into the red spectrum of light, because that is the wavelengths get stretched, right? It's almost like when you hear a car coming towards you, and it's like, and then it gets long as it goes past you and starts going away from you. Then well, that's the red shift, right? So that's sound, obviously, but when we're talking about light, we can tell the difference if something's coming towards us, if the waves are getting compressed, or if going away from us, if it's getting expanded. Oh, we got a comment here. Manju, thanks for hanging out this morning. Let's see what you got to say.
Yeah, thanks for the talk, philosophy. But I don't know if you know, but for the last like 5 or 6 minutes, we could not hear anything.
Oh.
I thought the app went dead, but we did not hear anything from you for the last maybe
well, let's see.
4 or 5 minutes.
Okay. Well, I see my mouth moving now, so hopefully it is working now. I don't know. Maybe that was. Well, you can watch me on. I am on YouTube Live as well under Philosophy Man 76. But thank you for that comment. Hopefully I'm working now. I do see my mouth moving, so hopefully you can hear me. I did plug my phone in, so I hope that didn't click off my sound to stereo. But anyway, so the redshifting. So the idea is that we notice that most of the things in the universe it's separate. It's moving away from it. Everything is expanding. The universe is expanding, and so if everything is expanding, everything is moving away from each other. Then that goes to logic that in the past things had to be closer, right? And this is how they came up with the age of the universe being 13.8 billion years, because they looked at the current expansion of the universe and they said this is how long it would take for all these things to, based upon how far away they are right now, to return back to if they were all in one spot, right? And so that's how they came up with the age, and that's what redshifting is, and that's what the Big Bang is. But the beginning of the singularity and what came before the singularity, that the Big Bang theory doesn't talk about. It's almost like when these same people debate against evolution, and they always want to say, well, how did evolution start? Where did and it's like, well, that's not what evolution is about. Evolution is about how things change over time, not about how they start. You're asking a different question. Evolution talks about one thing, and you're asking, well, what was the first? How did life start? How did the cells go? And it's like, okay, these aren't questions about evolution. These are questions about something else. So the Big Bang theory is the same thing. It's saying that everything in the universe expanded from a singularity. If you ask the question, what happened before the singularity, Big Bang theory doesn't explain that. That's not what it's explaining. It's a different thing. They don't know. We don't have an answer for that. Right. So, but the idea, but then they jump on that. It's like, well, if you don't know, it must be God. right? And that's that's just what's called God of the gaps, um, where you just insert God anytime there's a lack of knowledge. And we just say we don't know at that time. We don't have evidence of a God. We don't have evidence of anything else. So therefore, we don't. We can postulate we can postulate a hypotheses, and there's many hypotheses. And the one I was reading a second ago is one of those hypotheses, which I didn't finish. Let me pull it back up. Hopefully we can still hear. I'm not going to plug my phone in, so therefore, hopefully that was the problem. Where are my screenshots? Screenshot. Okay. All right. So Hawking's and Hartl's model eliminates the singularity using quantum cosmology. They treat the universe's early history as a quantum wave function described in the Wheeler-DeWitt equation, a quantum version of Einstein's equations. The universe doesn't, quote unquote, start from a point like explosion, but emerges smoothly from, quote unquote, nothing in a way that's finite but without boundaries. Finite but without boundaries. This goes back to episode 3, which is, are we in a black hole? Because that's what all these things kind of lead to us just being in the black hole. My personal belief is that we are a black hole of another universe, and that there's no beginning and no end. It's just universes inside of universes, and all of our black holes have a universe in it. And if you go to episode 3, I go through a bunch of evidence for that thought process. So I'm not going to do that now. But anyway, because that'll be another tangent. That's a whole show. Anyway, so let me go back. The universe doesn't start from a point like explosion, but emerges smoothly from nothing in a way that's finite but without boundaries, like the surface of a sphere, which has no edge or starting point. In this view, time doesn't have a beginning in the classical sense. Instead, but it's in bold. Instead, as you go back towards the origin, space and time blend together. Anyway, that's that. So I told her, I was like, don't read the cover. Actually read the book because there's more stuff here. Let's see. Time isn't a hard stop. Like to say like what happened before time doesn't make sense, because before is a function of time, right? So if time in this universe started at the Big Bang, to say what was before that doesn't mean anything. Now, I don't think time started then. I think time for this universe started then, right? Because in order for there to be time, you need space, and forever to be space, you need time. Right? If everything's in a singularity, which is what is at the center of a black hole, if everything is at a singularity, then you don't need time because there's no space. There's no time is a measurement of passing from one moment to the next. But if everything is in one spot, then there is no passage of time. There's no need to go anywhere. Everything is in one spot, right? So it's the same. That singularity is the same. There is no minutes. There's no now. As soon as that singularity expands, and there's a little bit of space, now time, because it would take time for one to get from one point to another point, right? Even if you're at Planck time, right, which is I gotta forget. Planck is really, really, really small. Let's just put it that way. Extreme smallness is Planck. Oh, my show went away. Why is that? Oh, I guess that's what happens. Is that true stereo? Hold on here. All right. We have to change the topic. I think I'm just going to talk space and time for a little bit. So anyway, So that's what happens. I guess if you leave stereo to go read something, then it kicks you off the app. Let's see. Maybe I can get super high. Will he pick up? That's the question. Nope. Oh well, we tried. Anyway, so getting back to it. Sorry about the little technical glitch there. I just found out again if I leave the app, and then it kicks everyone off. That makes sense that would happen. Where was I? Time and space. So before, yes, to say that there's what was before time, it's like saying what's north of the North Pole. It don't make sense. There is no north of the North Pole. Every place you go from the North Pole is south. Every place you go from the South Pole is north. So the idea and concept of what was before time, it doesn't really make sense. Now, before time in this universe. Now, if you ask me what my personal belief is, what happened before the singularity is before the singularity. There's no, well, it's no before actually. It's just time just never stops. Like we were just time for our universe. It was just another universe that we're in, that our universe is in. So, so there we go. So anyway, so yeah, I was talking about so yeah, so you have to dive a little bit deeper. Like we accept these things, and I was talking about the North Star. We accept these things and titles and phrases and as true, like, oh, the North Star is the brightest star in the sky. Well, it isn't. It's the 49th brightest star. Now, why do we believe that? Again, as I said, number one, because no one really looks into it; they just assume it. Number two, it's what used to be used for ships for navigation. People would look for the North Star when you get lost. It'll help you determine north, right? But the only thing special about the North Star is that it happens to be directly in line with our North Pole, right? So if you're standing at the North Pole and you look straight up, you're looking at the North Star. That's it. Now, why does it look bright? It just happens to look bright because the North Star Polaris just happens. It's just in a region of space where there isn't really cosmically any activity around it. It's like a star. Now, if you want to find the North Star, the easy way to find the North Star is if you look at find the Big Dipper, right? And then if you look at the two, like if you're thinking of the Big Dipper, that's the you have the handle, right? And then you have the pan. That's four stars that make the pan up of the Big Dipper. Well, if you follow the bottom right and top right sides of the pan, so the opposite sides away from the handle, and you follow those two stars and go up, in your sight north of that. Well, I guess of course it's north. You'll find a North Star. So that's how you find it in the sky. So you find the Big Dipper, you look at those two stars, and you just go in that direction continually in a straight line, and then you'll run right into Polaris. Now, the cool thing that I learned from Star Talk is if you think about where Polaris is, right, or the North Star is, it's if you think of it in relationship to the equator, okay? So if you think of it in relationship to the equator, it is at 90 degrees, right? Because the North Pole runs perpendicular to the equator. Now, every latitude below that is actually telling you at what degree you are to the actual equator. So if you're looking, like I'm in New York. So in New York, let me see. Actually, let me ask. I will ask. Oh, of course. Now I'm gonna mess up stereo again. What is the latitude of New York City? What is the latitude of New York City? Oh, okay. Can't hear my voice. All right. Oh, okay. Didn't kick me off stereo. All right. I'll use my other computer. Apparently, I have too many gadgets that I'm trying to use at the same time. All right. Let's see. I think it's 42 degrees latitude, but let's figure it out. Oh my goodness. What is the latitude of New York City? I was close. So it is 40.7128 degrees north. All right. So what that means, so if you think of that when you're looking at the North Star from New York City, the North Star will be 40 degrees in the sky, perpendicular to 40-degree angle to the equator. Right. That's what the latitude lines are. Right. So we're 40. So when we look at the North Star, we're looking at it and we're 42 degree or 40.7 degrees. Like you want to say 42 now. So when you go to the equator, it's like that's how far. When I say that, I mean that's how far the North Star is down in the sky, right? Because if you look straight up from New York City, you're not going to see the North Star, right? Because you're not at the North Pole. It's right. It's directly above the North Pole, not directly above New York City. Even though everyone in New York thinks that we're the center of everything, we aren't. Well, we are actually, but everywhere is the center of everything. But that's a whole nother conversation. Um, so, but where we are is we're actually, if we look up and we see the North Star, it'll be we'd have to look 40 degrees from straight up, and that's how we would find the North Star because it's 40 degrees in the horizon because that's where we are on the round Earth. Now, what's cool then is if you go to the equator, and where would you find a North Star? Well, you would find it right on the horizon. You'd have to look on the horizon to see the North Star because 90-degree angle, right? And if you go below the equator, you can't see the North Star because we're on a round Earth. So, and by the way, at the equator, you can't see the Big Dipper, right? Because it's south of the North Star in the direction that it's going. So once you're below the equator, you can't look up to see that constellation anymore. So I thought that was all interesting. I thought it was an interesting concept that I never thought about. And so, yeah, that's again how this is how they would use the North Star for navigation. I'm assuming like there's people who are getting sailing and ships, about navigation that learn all this stuff and are listening to me like, oh yeah, you're kind of silly. But I think everyone else, if you're like me, didn't know this. So North Star, not the brightest star in the sky. What is the brightest star in the sky? Oh, curious. Brightest star in the sky is Sirius. I think I even knew that. The brightest star in the night sky is Sirius, also known as the dog star, shining with a magnitude of negative 1.46. I don't even know what that means. Making it nearly twice as bright as the next brightest star, Canopus. It's a binary system located 8.6 light years away from constellation Canis Minor, the greater dog. Cool. Its brightness comes from its luminosity and close proximity to Earth. the planets like obviously planets like Jupiter and Venus outshine it. Yeah, of course. Well, that's planets are the brightest things in the sky because they're the closest to us, and they're not bright because they're shining. They're bright because they are reflecting the light of the sun, just like the moon does, right? So the moon doesn't would be dark if it wasn't for the sun. So, and that's why we get phases of the moon, because the moon goes around the earth and it's facing the sun in different angles. Um, and that's why it gets lit up. So anyway, um, I feel like that's all I wanted to share today. This is gonna be a short episode of Cosmic Matters. Um, just some information about stars and the universe in general. And yeah, wanted to jump on, do an episode 20. Shout out to G. We'll keep this one short, a little Big Dipper, a little explaining the round earth, and all that type of stuff. And then also, and just talking about the philosophy of understanding what you're talking about. I find for me, when I'm talking to people, and this is probably it's an issue that I have. It's almost a little bit of an imposter syndrome, that I'm always questioning what I think. And that's what we should all do. We should all question when we say things. Instead of being so sure of ourselves in our hubris, we should actually look them up. Maybe I'm not right. Maybe I'm wrong here. Let's find out more information. This is how we learn. This is how we grow. This is how in general things are. When we make statements, we think things about ourselves, about other people, about the world, about the universe, about everything we live in, and understand everything that we take in is our perceptions. It's not necessarily the truth. It might be true for you, but objectively it might not be true. And it goes through our biases and our lived experiences, and even our senses. These are all fallible things. So it's always strange to me when people are so certain and yet know so little. So make that a note to everyone to always, this is why when you talk to scientists at a convention or something, they're always putting caveats. They're always saying things like, as best as we know, to our most current knowledge, according to all the studies that we've done so far. They're constantly saying things like that, and never having certainty, because how can we? The universe is constantly changing. It's constantly moving. We're constantly getting more data. Our instruments, our knowledge of the universe is only as fine as our instruments are about the universe. That's just how it goes. Like if we say something is an inch and we put a ruler next to it and we say it's 1 inch, well, but what about the mark, right? Doesn't the mark, how thick is the mark, right? When I say the 1 inch mark, right? So is it in the middle of that mark? Is it at the beginning of that mark? Is it at the end of the mark? So you can always get finer instruments, finer tools to work and try to discover more about this wonderful place called the universe that we live in. So, all right. With that being said, I'm working, basically spending most of today working on my new community, which we'll be talking about wealth building. If you want to check out my website, it's matthew.washington.com. It's still working on it. And that's what I'm going to be doing most of today, which is why I'm kind of cutting today's cosmic and philosophy talk short, because I need to build that up, and I will be doing a lot more wealth building and mindset, personal development type of stuff. I will still keep doing this on Sundays. This is kind of be my release, but I'm just trying to get that website up and the community up and going. It's called Bright Futures, and you can definitely look that up, and you can just go to Matthew.Washington. Not Matthew.Washington, excuse me, Matthew-Washington.com, Matthew-Washington.com. And now my website for teaching financial literacy and investing and wealth building and all that kind of stuff, if you're interested in that as well. All right, so that's going to be it for today for Cosmic Matters. Short one here today, but I will be back next week. We will get into more more philosophical conversation. Keisha, thank you for joining. I see you are on the stereo, and I will see you next Sunday. Enjoy the rest of your day.